Okay, we're going to start section 2.1. Section 2.1 is an introduction to subunit. Before we start, as it is usually the case, we want to define the definition before we begin working problems. So let's define a set. A set is a collection of objects together with a clearly defined characteristic that determines whether or not an element, an object, belongs. We sometimes refer to objects inside a set as elements, whether or not an object belongs to the set. That is, an object is an element of a set. Okay. So let me give you some time there to copy the definition. So a set is a collection of objects together with a clearly defined characteristic that determines whether or not an object belongs to a set. In other words, an object is an element of the set. Okay. Let me go ahead and share my screen here. 1 second, let me get to the right place. Go to the workbook, section 2.1. And so we're going to work some of these examples. And for this one, it says write number 1, example number 1. It has 5 parts. It says write the set using roster notation, do not include repeats, use the ellipsis button if necessary, and give at least 3 terms before the ellipsis and at least 2 terms after the ellipsis. If the set is not well defined, state so. Okay, so let's take a look at 1A. And roster is the roster method. It's very simply put is just listing every element of the set. But remember, first we have to see if these are sets. And for a set to be a set, you have to have a collection of things or objects with a clear definition that tells you whether or not an object belongs to a set. So 1A reads the set of planets around our sun that begin with the letter M. And so we see that example 1A, let me just write down this thing here, example 1A. So 1A, I can write the set, right? And there are 2 planets, I think, yes, Mercury and Mars, or Mars and Mercury. And the way that you would write it using roster notation is like this. You would use the, these are called the, this is the set notation, braces sign. The sign of these signs are used for, we use braces whenever we are talking about sets. And so we always use this, the braces around the elements of the set. So here we have a set that has 2 elements, Mercury and Mars. And notice that we were able to create this set because we had a clearly defined set, right? It's a well-defined set. There's a definition that clearly identifies the elements of the set, all right? So then you would do This is the roster method. Remember, the roster method, let me just write it here so you have, is lists every element of the set, if possible. If not, now there's another way we can use the roster method. You know, if the set is very big, if we have a very big set, I'm going to show you how we can still use a roster method without having to list every element, but giving the reader clear indication of what those elements are. Okay, so so another way is we use abbreviation. Okay, if the set is too large, and I will explain what that means, and I will show you with when we get to that example. Okay, so let me go to the next question here. Always remember to have your workbooks open, okay? So that you can follow me as I'm doing these problems. Notice, let's just read through these. 1B, the 5 best restaurants in San Antonio. That's not a well-defined set. So 1B is not a well-defined set. So why? Because it relies on opinion, right? On personal opinion. My set more than likely will not be the same as someone else's set of 5 best restaurants. My choices are going to differ from the choices of other people. So that's not a well-defined set. So for example, 1B, we want to say not well-defined. Okay, so for 1B, remember, it's not well-defined. 1C, the set of even numbers between 1 and 11. Well, that's a well-defined set, right? We can, so even numbers between 1 and 11, if I write it in roster method, even numbers between 1 and 11, so we have 2, 4, 6, 8, 10, right? Even numbers between 1 and 11, well, we know that 1 and 11, those are not even numbers, so any even number between those two numbers will be inside an element of this set. Okay, so if you write it in roster method, you would have the set notation, the braces, and then 2, comma. Notice that I have to put a comma after each element. 2, 4, 6, 8, and 10. Okay. Okay. Now you get the idea, right? So the list of US presidents through the year 2020. Okay, so this is an example of a set where you can use what we call the like when we can still use a roster method, right? But we're not gonna list every single president, right? We're not gonna do that. So there's a way you can do this. And so the way you can do this is you can use a roster method and you can list, for example, the three of them, right? So I'm just picking some from the list here because I'm looking at the list that they have. And so I'm just gonna follow what they did, but you can do it in any other way. So notice how, let me share my screen here. Oh, you're really looking at what I'm writing, good. Okay, so here I write the first 3 choices, right? First 3 of the US presidents, Washington, Adams, Jefferson. And then when I write a comma after the Jefferson, and then 3 dots, and then another comma. Why, what's this notation? Is letting the reader know that this list continues, okay? So there are more elements, not just 5 presidents. And notice the last 2 presidents I write, right? So this is one way you can still, even if the set is very large, you can still use a roster method, but make sure that you don't forget the commas and the three dots. This lets the reader know that the list continues, the set is not over yet. So we have all these presidents, right? But we're not gonna list them all because the set is just, it will take too much time. Okay? So let me see. We can go to, so I hope this is making sense. I'm gonna do some from example 2 so you can get more practice. Let me share my screen. Let's go to example 2, and I want to do some of these with the to explain the symbols here. The notation in example 2 may not be familiar to you, so I'm going to explain. This is not, when you look at example 2A and 2B and 2C and 2D, that's not roster method anymore. That's called the set builder method, set builder notation. And this is different in the sense that it doesn't list the elements, it gives just a description or a definition of the elements. So when you look at 2A, for example, it says set Z is a set of all the x's, and then that line, vertical line, you read it such that x is an element of n. That means x is a natural number. That E, well, the symbol that looks like an E, it means belongs to or element of. So this reads x is an element of n. That means x is a natural number. And x is between 207, meaning you see that it doesn't have a line under the inequality sign. So that means it's greater than 207 and less than or equal to 324. So less than x, right? 207 is less than x, or x is greater than 207, and x is less than or equal to 324, or 324 is greater than or equal to x, right? A natural number. So we have to define several things here. So let me write this problem and then I will break it down, okay, step by step, because like I said, this notation may not be something you're used to seeing, so I'm going to explain. Again, this is not roster anymore. This is a set builder notation, and I'm going to explain everything here. So next time you see something like that, it makes sense. Okay, so let me stop sharing here. Okay, so this means x. So this is the set builder notation. Okay, set builder notation. And the way you read this is x is a natural number that this symbol here, this means element of or belongs to, okay? That means belongs to or element of. So belongs to, or it also means or element of. So belongs to or element of. X is a natural number, so x belongs to n. X is a natural number, and x is greater than 207 and less than or equal to 324. Okay, so if you were to graph this, let me show you on the number line what it would look like. So here is x, and x is between 207 and 324, but it's not, it's greater than 207, so put a parenthesis around 207, and it can be less than or equal to 324. So I put a bracket. Bracket means that it can equal 324, and the parentheses means that it cannot equal 207. And then any number between these two numbers, right? But not including 207 and including 324, x can be any number between those, as long as these restrictions are satisfied. So now, the question here is that they want us to write the set. Let me look at the instructions again. Write the set using roster notation. Okay, so the roster notation, they want the roster notation. And they're giving us a set builder notation here, but they want us to write it using roster. So using the roster notation, I would write like this. I wouldn't count 207. Now remember, natural number, if you're not familiar with the natural numbers, I can just give you a definition here. The natural numbers, so you know what those are, anything from 1, 2, 3. So these are whole numbers, but not including 0. Although some mathematicians do include 0, but we will not include 0 here. It will begin with 1, 2, 3, 4, 5, 6. No fractions here, so just whole numbers. So then all the way to infinity. And so if we know that now the definition of natural numbers, so the set will include 208, right? Because remember, the parentheses means that you don't include the 207 because you don't see a line under the inequality sign here. Let me lower this. There's no line here for equal, so it has to be less, right? 207 is less here. X has to be greater, or 207 is less than X. So then you start with 208, 209, 210, and then remember to use the 3 dots here after the comma, and then another comma, and then list the last two. You can list 323 and 324, and then close the set. Okay, that's in roster method. So the set builder notation, the set builder notation, or the set builder method, it's the set builder notation. You don't have to list every element of the set. It is enough to describe the set, right? So we're just describing the set. The set Z is a set of all the x's such that x is a natural number and 207 is less than x and x is less than or equal to 324. That is a description of the set, right? That's the set builder notation. So that's describing the set or writing the set using set builder notation. And the roster method, this is a roster method where we list every element if we are able to, if it's a small set, and if we're not able to do that because the set is too large, we list the first 3 plus we let the reader know that the list continues with the comma, the 3 dots and the comma, and then the last 2 elements. Okay, so that is 2A. And so you can do, let me share my screen here. So okay, so you can do these for 2B. For 2B, I wonder if that's a 0 or if that's the empty set. It's kind of strange. No, I don't think that's the empty set. X belongs to, let me see, that's interesting. Let me just take a look at something. Give me just 1 second. Just 1 second. To maybe the integers or the full numbers. I don't know which notation he tried to use here. Okay, well, we're gonna, let me do a screen share so we can continue. All right, so let's take a look at set E and greater or equal to, where are these defined? Let me see something here. 1 second. Okay, we'll get back to some of these questions here. Let's take a look at 2D. 2D, notice that set Z is a set of all x's such that x is a young person. That's not a well-defined set, right? We can't list the elements of this set in roster. And similarly, I want you to tell me something. Well, let's answer the question, is 2D a well-defined set? Well, no, because nobody's defining here a young person, right? What is young to, I mean, who is going to define young here, right? So we can't really write this. This is not a well-defined set. So 2D, not a well-defined set. And let me see something here up here if that was defined. The set, I have to look at 2A. No, I have to look at 2B and 2C because belongs to O and belongs to E. I'm trying to see what, we will come back to 2B and 2C, okay? So let me take a look at that one because I don't, what notation is that? I don't know what the notation that, maybe he meant integer, but that would be the set C. All right, so don't worry about 2B and 2C for now. Let's move on to example number 3. And here, remember that this sign E is an element of or belongs to. So whenever you see that sign that looks like an E, it means that a number or an object belongs to the set. For example, 3A is saying that 19 belongs to the set 1, 4, 7, 10. And so in order for that to be true, 19 has to be one of those numbers inside the set. So we have to figure out the pattern in 3A, and then we have to figure out the pattern in 3B, in 3C, and in 3D, right? So we have to see if that is the case. Now, I want you to see for 3A, is 19 an element of that set? Well, we have to see what the elements of the set are. So let me write it here so we can figure it out. Remember, we need to say, is it true or false, right? So true or false. So let me write this. It says 19 belongs to 1, 4, 7, 10, and then dot, dot, dot. The dot, dot, dot means that it's continuing, okay? So we have to say, is it true or is it false? Okay, so, well, what is the, we have to see, what are the elements here? So 1, 4, 7, 10, and notice that we are adding 3 every time, right? So the next number would be 13, then 16, then 19, then 22, then 25, and it keeps going, right? So this is an infinite set, but the question here is 19 an element of the set? And we see that, yes, it's in there. We didn't write it. We don't have to. We are letting the reader know that this set continues because after this comma, there's 3 dots, which tells the reader it continues. So this is an infinite set, and 19 is an element of this set, right? So this is true. Remember, this means belongs to, this symbol here belongs to or is an element of. So we're saying 19 belongs to the set or 19 is an element of this set, right? And so the answer is true. Okay. All right, the next one, let me see. The next one, 3B, I'm just going to write them here. Okay, so 3B, we have 23 belongs to the set 1, 5, 9, 13, dot, dot, dot. All right, so we have to see if that is true. Let's see, so 1, 5, 9. So we went from 1 to 5. And so from 5 to 9. So we're adding 4 every time, right? So we're adding 4. So then the set is 1, 5, 9, 13, 17, 21, 24, and so on. So notice that 23 doesn't make it, right? So this is false, right? You see that this is false because 23 does not belong to the set. Once you write the elements of the set, you write enough elements, not all of them because this is an infinite set, but if you write enough elements so you can see if 23 belongs to the set, you see that it doesn't, right? So that's false. All right. And so I want to do also, let's do 3C. So you can see 3C. It says Y does not belong to the set of vowels, right? Now notice notice that this is actually true, right? Because Y does not, when you see the element symbol or the belongs to symbol with a line across like that, it means does not belong to. So this means does not belong to or is not an element of. That's another word to, it also means is not an element of. So this is actually true, right? Because Y does not belong to that set. Okay, so that's 3C. And then you can do 3D. I'll let you try 3D. And okay, so notice that this is this section is not too bad, right? So let me see what's next. Just give me 1 second. Maybe just 1 second. Okay. So let me share my screen now. So we can, I just wanted to see what was coming after in your workbooks. Let me share my screen. There's a lot of problems here. So, okay, now it says, for each set below, write the set using the descriptive method and write the set using the set builder notation. So remember, we talked about set builder already, and then the descriptive. The descriptive method and the, let's do the set builder first because you're used to that, right? So, so let me just write the problem and then we'll do it together. And then I'll stop sharing so you can see what I have. So example 4. And then I have the numbers, the elements are 110, 111, 112, 113. And let me stop sharing here so you can see. And now we're going to try the descriptive method first. And then the set builder. Oh, we said backwards, right? We're gonna do the set builder first. So set builder. So the set builder notation is gonna just give a definition of the set. So one way you can define this set is by looking at the numbers and seeing, okay, what are they? These are natural numbers, right? 110, no fractions, 110, 111, 112, 113. So using the set builder notation, I can, you write the set notation and you can use, X. You can say the set of all the X's and then the line like this, you read it such that, or this line, it's to separate the definition. So you're gonna define the set now. So what is a set? Well, X is a natural number. Remember how we write that? X belongs to N. X is a natural number, then we can write it using set builder notation like this. X belongs to N, and then you want to say, and X is between 109 and 114, but not including those numbers, right? So you can write it like this: 109 less than X less than 114, right? That's one way you can write it. Or another way you can write it, I mean, this is one way you can write it, but you can also write it starting at 110, right? But you have to put the equals under, right? But this is one way you can write it. Remember that. Now, another way you can write it, let me give you that other way. So you can say X is a natural number and 110 less than or equal to. This is still true. This will be true also. Okay, so both of them would be right because you're saying the same thing here. Okay, so here we're starting at 110. Notice that I put the line under the inequality sign. That means that I am including 110 and I am including 113. Over here, I am not including 109 and I'm not including 114, but these are exactly the same sets. Make sure you see that. Okay, so using the set builder notation, okay, that's one way to write it using the set builder. So that's that would be for B. So I did part B because we were used to that already, right? And if you want to use, it's also asking for the descriptive method. So that's just writing a sentence. You basically write what the set is with a sentence. So you can say, using the descriptive, let me see. So hold on, what's it say? Descriptive method. Okay, so let me write this down. Descriptive method. Okay. And so for the descriptive method, you can write, let me raise it up a little bit here so you can see. You can write for the descriptive, you can say the set of natural numbers between 109 and 114, just write a sentence. The set of natural numbers between 109 and 114. Okay, so that's the descriptive method. Okay, so let's see, what else do we have here? I'm just looking at, there's a lot of problems in this section. This video is going to be a little bit longer than the other videos, for sure. Wow, there's a lot of questions here. Okay, so let's keep moving along. Let's see. We have to talk about, let me share my screen. Hold on, where are we here? Okay, so we did the descriptive method. Okay, we have to talk about the empty set. The empty set is a set that contains no elements. And so sometimes the students get confused by the empty set. The empty set, I'm gonna give you the definition of the empty set, and then let me stop sharing here. So let's define the empty set. First of all, the way you represent the empty set, we have a circle and then a line through it, or the braces without any elements inside, or also you call it the null set. We call it the null set as well. So these are three ways to represent the empty set. And it is a set that contains no elements. Okay, so that's the definition that we will use, is a set that contains no elements. And let's see, let's go to the problems here. Okay, so we'll go through number 6, and you can try number 7. Oh, actually, I have to do 7 too because it talks about cardinality. Okay, so definitely 6 and 7 are going to be important. And then 8. I won't do every single problem, but we definitely have to cover these problems. At least some of them, right? Because let me just scroll down here. Okay, yeah. So yeah, it's a long section, but we need to go through it because I know you'll have a lot of questions on this, right? And so let's go to number 6. And so now you know the definition, right? And so which of the following sets are empty? Circle the empty sets. Okay, so example number 6, we're gonna go through A, B, C, D, E, F, and G, and we're gonna discuss them, and then we're going to decide whether they're empty or not. Okay. All right. Now, set A is a set that has one element there, and that element is 0. Okay. So that is not empty because it has an element. So we're gonna write not empty. Okay, right next to A. Okay, set B has, notice that set B, even though it has the empty set inside, now the set B, look at the braces around the element inside the set. So set B has one element, and that element is the empty set. Now, just because the empty set is empty, it doesn't mean that B is empty. I'm gonna say it again. Just because the empty set is empty, that doesn't mean that B is empty, because B does have an element, the empty set, even though, of course, the empty set is empty. But we're not talking about the empty set, we're talking about B. We're not talking about the empty set, we're talking about B. Is B empty? No, because it has an element. What is that element? Is the empty set. It's inside the set B, right? So that's not empty. So we're gonna write not empty for B. Okay. And I'm going to share what I have written here, but I have to be sharing my screen to answer the questions, and then I can share what I wrote on the paper. Okay, look at set C. Set C is empty. In fact, it has the sign, right, for the empty set. That's the way one of the ways we represent the empty set is with the braces without any elements inside of the set. So C is empty, right? You can see that. So this is empty. And then D, that's not even a set, so that's the number 0, so not empty. And E, this one, I have a lot of fun with this one. The students want to argue with me that this is empty. Sorry, that this is not empty. I tell them it is empty because there's no way we can find a flying pig. And so unless you find a flying pig, then that set is empty. So just because you write it a description, it doesn't mean the set exists, right? So existence, the definition doesn't make the set, doesn't imply that the set is going to exist. So that's empty because there are no flying pigs. So E is empty, right? So that's an empty set. And then F, let's read it. So F is a natural number between x is greater than 8. Okay, so x is greater than 8, so that means 9, 10, 11, 12, because it's a natural number greater than 8 and less than or equal to 2. Well, it cannot be greater than 8 and less than or equal to 2. So I want you to see how that's a contradiction right there, because a number cannot be bigger than 8 and at the same time less than or equal to 2, being a natural number, right? So you can see that that is empty. That's an empty set. And then G, that's the notation for empty, so that is an empty set, right? And so let me stop sharing here so you can see what I wrote. So go ahead and take a look at what I wrote here. These are the answers here. And while you do that, I'm going to look at what the next question here. We're going to talk about cardinality for 7. And then what makes a number, what makes a set infinite or finite? Okay. Okay, so we're almost there. We're almost there. So we're just gonna do problems 7, 8, and 9 for the sake of 9, and then perhaps 11 and 12. We will see, because I don't want to make the video so long that it's too long of a video. We don't want to make those videos really long. So again, if you need additional tutoring, you can always you have two options, because I know that some of the material may get a little hard. So if you want to meet, you can meet with me for tutoring, or another option is to visit Virtual Math World. Remember that you have awesome tutors that you can go there and get a one-on-one tutoring via Zoom. Okay, so don't think that you don't have any help. You definitely have your professor or the tutors in Math World. Okay. All right, let me go ahead and move on to the next question. Go to so that's example 6. We're gonna go to number 7 now. Let me share my screen here. We're gonna talk about cardinality of a set. And the cardinality of a set is the number of distinct elements in the set. So let's write the definition. Cardinality of a set and let me stop sharing so you can see what I'm writing here. The number of distinct elements in a set. The number of distinct, notice distinct, okay? So you don't count, if an element repeats, you don't count that. Okay, sometimes it gets a little blurry and then it gets better. So cardinality is the number of distinct elements in a set. So let's go to question number 7, and it has several parts. And we're gonna find the cardinality of 7a. And the notation for cardinality, I will explain. But notice, let's go ahead and see. So how many different or distinct elements do you see in set A? Well, we have 1 and then 1 and then 2, 3, 5, 8, and 8. Okay, so the 1 only counts once. And then 2, that's another element. 3 is another element, 5 is another element, and 8 is another element, right? So it's 1, 2, 3, 5, and 8. 1, 2, 3, 5, and 8. So the cardinality of set A is 5. How do you write that? Okay, so how do you write that? You're gonna write it with N, with the letter N for number of elements, okay? And then in parentheses, you write the set A, and then you write equal to 5. This means the cardinality of set A is 5. Okay, that is what it means. The cardinality of set A is 5 or equals 5. So remember the N, the letter N is for number of distinct elements. And then in parentheses, you're gonna write the set, the letter representing the set, and then equals the number of distinct elements in a set. That is the cardinality of a set. All right. And similarly, let's go ahead and answer the other parts of the question. Now, 7b, notice that B is the empty set, right? So B equals the empty set. So that means that the cardinality, so because B is the empty set, B is empty. This means, so I'm just writing this down. This means the cardinality of B equals 0. Okay, and the way you're gonna write this is cardinality of B equals 0. So this is how you will write it. Cardinality of B equals 0, okay? Because B is empty. Okay, so because B is empty, that means its cardinality is 0. All right, so okay, that's 7b. Now 7c, let me write the set here. So 7c, let me make sure you are able to see clearly. Yeah, 7c. It says C is a set of all the x's such that x is a natural number and x is less than 7. Well, let me write it. This is, remember, what do we call this? This is a set builder notation, right? This is a set builder notation. Now I'm going to write it in roster method so that I can see what the elements are, right? The roster method. So I know that x is a natural number, but it's less than 7. So it's going to be 1, 2, 3, 4, 5, and 6, right? Because the natural numbers start at 1. And because it has to be less than 7, then it goes all the way to 6. Okay, so what is the cardinality then? Well, then the cardinality of C equals 1, 2, 3, 4, 5, 6. Right? That's the cardinality. The N, remember, represents cardinality. And then 7D, D is the empty set. Right? Is that correct? If you were here, I would say, no, that's not correct. D is not the empty set. D has one element, the empty set, but D is not the empty set because D, remember, D is represented by these braces. So D is actually not empty because D has one element. D has one element. So note that D has one element, namely, what is the element? The empty set, right? That's the empty set. So the cardinality of D, because it has one element, is 1, right? The cardinality of D is 1 because it has one element. All right? All right, so that's a question. That's question number 7. For questions 8 and 9, I have to give you some definitions. And then, so we will do questions 8 and 9. 8 has several parts. And then 9 is just one question. And then we'll do maybe another question, 11. And then we'll stop there because in order not, I don't want to make the video too long. The purpose of the video is to cover every topic that you will encounter for a particular section, so that when you go to the homework, you know what to do. Okay, so let's take a little bit of a break and kind of review what we have done in this section, because this section is very different than what we were doing previously, right? And one thing about this course, I want you to know something about this course is that this course has a variety of topics. You're not going to be bored in this course because it covers uh, so many different topics. And so last video, we talked about problem solving, right? The last two sections, we talked about problem solving, and then we talked about estimating, and then we talked about inductive reasoning and deductive reasoning. And then now we talked about real numbers and fractions. And so it's just been a variety of topics. So you, like I mentioned, you will not be bored in this course. It's just, but if you do have, if you find yourself, you know, with lots of questions, make sure you email me so we can meet for tutoring, or reach out to the tutors, but don't fall behind. Okay, so let me share my screen so we can go to question number 8. And for question number 8, I need to define infinite and finite. And infinite set is one set that is infinite in the sense that it has an infinite number of elements. There's no end to the number of elements in the set. So that's an infinite set, that the elements continue to, you can never reach the last element. And finite, it means that there is a last element. So, but how do we actually know if a set is infinite or finite? We look at the cardinality. If the cardinality is a natural number or 0, then the set is finite. If the cardinality is infinite, then the set is infinite. What does that mean? Cardinality refers to the number of distinct elements in a set. Once again, cardinality refers to how many distinct elements there are in a set. So the cardinality tells us if the set is infinite or finite, because if there is an infinite number of elements, then we know the set is infinite. But if there is a number that we can assign for the cardinality of a set, if it's a natural number or 0, then we know it's a finite set. For example, when you look at 8a, the set A is a set, and remember, what notation is that? That is a set builder notation. What is the cardinality of that set? Well, let's see. 8A, reading it together, the cardinality of A is, let's read it together. The set of all the x's such that x is a United States state. That means that it's finite because the cardinality is 50, right? So there are 50 states. There are 50 states, and so the cardinality is 50. So this is a finite set. Okay, so I'm gonna just write it. We will do it. Let's answer the questions verbally, and then I'm writing them down too. So then I'll do a screen share so you can see what I wrote. Okay, 8b. B is a set of natural numbers such that z is greater than 9 and z is less than or equal to 1. Okay, for B, I'm going to write set B. This one does require that I write it so you can see. Okay, so this is in set builder notation, right? But I'm going to write it in the roster notation. I'm going to do 8B and you can do 8C because they're similar. So let me stop sharing here. So this is in set builder notation, right? Set builder notation. So if you write it in using the roster method, you have B equals a natural number greater than 9, but this means and, this symbol here means and less than or equal to 1. Okay, so a number cannot be both greater than 9 and less than or equal to 1. It cannot. Think about it. If you draw the number line, okay, here's 9, right? And then here's 1. So z has to be less than or equal to 1. So that means that z is over here. But then at the same time, z has to be greater than 9. So that means that z has to be over here. It cannot be in both places at the same time. The key here is to know that it has to be at the same time in both places. That cannot happen. So B is the empty set. You can also write, you can write it like this, right? You can also write it like this, right? You can, the empty set. So B is the empty set. So B is empty. So therefore, what is the cardinality of B? The cardinality of B is 0. So this is also a finite set, right? So it's finite because the cardinality is 0. So whenever the cardinality is a natural number or 0, then that means that you have a finite set. So finite set, this is a good place to define a finite set. A set is finite if its cardinality is either 0 or a natural number. A set is finite if its cardinality is either, so if it's 0, like in this case, or any natural number, then you know the set is finite. Okay, so this set is finite. Okay, so that's 8B. And I apologize for the length of this video. There's just too many questions, okay? I'm so sorry about that. I know that usually the videos are 20 minutes, tops 30 minutes, but this one may go a little bit longer. Let's see, let me share my screen here. So that was 8B. Now, 8C, let's take a look at 8C. X is a natural number and X is greater than 7. So notice that this can work, right? So X is a natural number and X is greater than 7. That means that what are some of the elements? 8, 9, 10, 11, 12, 13, 14, 15, and then it goes all the way to infinity, right? So that's an infinite set because the cardinality is infinite. So let me write it so you can see. What we mean by that. Then you write 8C. And so X is a natural number. Oh, hold on. Sorry about that. I wrote it incorrectly. So X, 8C, is a collection. C is equal to all the X's such that X is a natural number and X is greater than 7. Okay. And let me stop sharing here. So what is, this is in set builder, right? Set builder notation. Okay, so if you write C equals in the roster, using the roster method, you can, so it has to be a natural number and greater than 7. So we start at 8, 9, 10, and then remember we can do it like this because we can never reach the end, right? But this keeps going forever. So the cardinality of C is infinity, right? How many elements, how many distinct elements are in the set C? Infinite. So this means that you want to write, so thus C is an infinite set, right? C is an infinite set because the cardinality is infinity, all right? Because its cardinality is infinity. And AD, it says D is a set of all the Y's such that Y is a whole number. Well, a whole number starts with 0. So if you write, this one is in set builder. So if I write it in roster, this is 0, 1, 2, and it keeps going 3, 4, 5, 6. I'm writing more than I should, but just to give you an idea, right? So the cardinality of D is infinity, therefore D is an infinite set. Okay. Yeah, because you can never reach the end. You can never reach the end of D. Normally we just write 3 of these, but because I'm not gonna reach the end, I want enough numbers here to kind of, so the reader can understand, right, what they look like, what the numbers are. All right. And let's see, so that's an infinite set. And then E, notice ADSS. E is a set of books that can be written. Well, I mean, that's an infinite set too, right? Because there's no limit to how many books can be written. So the cardinality of E is infinity, and therefore E is an infinite set. Once again, the cardinality of E is infinity, therefore E is an infinite set, because there's no limit to how many books can be written. All right. And we're going to come to the end of the section here. We will do, let's work number 9. And let's work 11 to give you an idea, and you can do the other two. So number 9, it says, but I have to give you the definition of equal sets, equivalent sets. So you need to know what an equal set is and what an equivalent set is. All right, so let me give you the definition here first. Equal sets and equivalent sets. Let me stop sharing so you can see what I'm writing. Equal sets and then equivalent sets. So equal sets, so 2 sets are equal. Two sets are equal if they have the same cardinality and the same elements. Okay, so 2 sets are equal if they have the same cardinality and they have the same elements. For example, notice, here's an example. A equals 0, 0, 1, 1, 1, 2, 3, and 4. And B equals 0, 1, 2, 3, and 4. Okay, so notice that they have the same elements, 0, 1, 2, 3, and 4, and they also have the same cardinality because you don't repeat these numbers, right? So what is the cardinality of A? 0, you have 0, there's 1, 2, 3, 4, 5. So the cardinality of A is 5, the cardinality of B is also 5, and they have the same elements, right? So A and B are equal sets. These are equal sets, A and B. So 2 sets are equal if they share the same cardinality and the same elements. So same cardinality, same elements. You have to check that they have the same cardinality and that they have the same elements. Both conditions must be true, must be satisfied. Okay, that is in order for the sets to be equal. That is in order for the sets to be equal. Now, what about equivalent sets? That's not equal sets. So equivalent sets, 2 sets are equivalent if they have the same cardinality. That's all they have to have. So 2 sets are equivalent. 2 sets are equivalent if they have the same cardinality. Two sets are equivalent if they have the same cardinality. For example, say A equals A, B, C, D, E, and B equals 1, 2, 3, 4, 5. You see how they're not equal because the elements are different, but they are equivalent because they have the same cardinality. The cardinality of both sets is 5. They have 5 elements, 5 distinct elements. 1, 2, 3, 4, 5, 5 letters. And B has 5 numbers, 1, 2, 3, 4, 5. So therefore, these two sets are equivalent. They have the same cardinality. The same cardinality is all we need to have equivalent sets. Okay. So what have we talked about so far? Let me just quickly review before we go to the next thing, okay? Which is just the examples to close. So topics that we covered in 2.1, okay? We cover the definition of a set. Make sure you understand this very well. And ways to write a set. Remember, we talked about the roster method. This is listing every element in the set. And when the set is way too large or way too big, we just list the first 3 elements with commas, and then 3 dots, and then comma, and the last 2 elements. And we use a set notation, the braces around the elements, okay? And then we talked about the set builder notation. And this is where we don't list the elements, we just describe a definition. We give a definition for the elements, right? That's the set builder. And then the descriptive method, which is to write a sentence describing the set, right? So we talked about ways to write a set, and then we talked about the empty set. And then we talked about cardinality of a set. And then we talked about equal and equivalent sets. So I recommend that you watch this more than once because set theory is new to most of you. So please watch the video. If you have time, watch it at least twice so that these concepts are very, very clear, okay? If you're struggling with any of these, or if you have a question about the problems we did not get to, and you want to meet with me, just email me and we can do a Zoom session during my office hours, or if you prefer a different time and I am available, we can schedule a time. We just have to work out the schedule that works for you and that works for me. But okay, so these are the topics that we have covered so far. We're gonna go to the last set of problems so we can close this because it's been a long video and I know you're tired. Perhaps you want to take a break. Okay, so let's take a look at 9. And 9, it's asking that we state whether the pair of sets are equal, equivalent, or neither. And so 9, so in which way are they describing these sets? In which way are they writing these sets? They're using the set builder notation where they give a definition to describe the elements of a set. Notice W is the set of all the X's. They're using the letter X to represent the elements. And then the line, and then the definition to describe the elements of the set. So then W is a set of all the X's such that X is a day of the week. So you have 7 days. So the cardinality there is 7. Okay, so I know the cardinality of W is 7 because there are 7 days in a week. Now F is a set of all the X's such that X is a month with exactly 31 days. Now we have to figure out what is the cardinality of F, because how many months do we have in a year that, okay, so you know that have 31 days. Okay, so W and F, So if you write the cardinality, so the set W is all the x's such that x is a day of the week. And then F is a set of all the x's such that F is a set of all the set of all the x's such that x is a month with exactly 31 days. Well, I know the card, and this is example 9. Okay, I know the cardinality of W is 7. Now, I know these sets are not going to be equal because the elements are not going to be the same. Okay, so we know they're not equal sets, right? We know that, but we want to see what is the cardinality of W. Well, we know it's 7 days in a week, so the cardinality is 7. I need to figure out the cardinality of F. Well, I have to figure out how many months in a year have 31 days, and let me research that. Hold on. I'll tell you right now. They should tell us here. Also 7. So there are 7 months that have 31 days. Okay, let me just make a note here. Now we don't have to list the months, but just know that there are 7 months that have 31 days. So that means that the cardinalities are the same. Now, are they equal? No, because they have different elements. And for the set to be equal, for 2 sets to be equal, they must have the same elements, right? They must have the same elements. So I know that the sets are not equal. So we write this, we have, let me go here. So we see that the sets are not equal because they have different elements. Right? The sets are equivalent because they have the same cardinality. So the sets are equivalent because they have the same cardinality. Okay, so that is the way we answer question 9. All right, now let's answer one more question. 11 we will do, and practice the other 2 that remain, and let me know if you have any questions. Again, the answers are in the back of your workbook. So I really hope this video helps you. There's a lot in this section, so I do recommend that you watch it at least twice. And don't ever go to the questions without watching the lessons, because it takes a lot of work to make these videos, and I'm making them to help you succeed. So please watch before you do the homework. And as you're watching, stop the video and make sure you're understanding what I'm doing. And if you don't understand, go back and watch it again. And if after you watch it twice, you still don't understand it, reach out to me, okay? So that I can explain it live. But I really do hope that these videos help you. I was just gonna release some lecture notes without videos, but since we have the technology now, we need to take advantage of it. So just because you're taking an online course, it doesn't mean that you shouldn't have access to live teaching. Okay, so I really hope that this helps you, and provide me some feedback. I truly appreciate the feedback. You can send me feedback via email. Always email me through your Canvas inbox, and provide feedback on these videos. If I'm going too fast, if anything that you want to add, I really appreciate all the feedback you can give me so that I can improve, because that is my desire, to improve the way I deliver the material to you so that you get quality teaching. And I take that very seriously. I love what I do and I want to do a good job. So let me know if this is helping you. Let me know how I can improve. And if you need live tutoring, reach out to me. Okay. So let's see. 11. Let me do a screen share. We will do number 11 and we will close with that one. And we're looking at the two sets, A and B. And we have, it looks like A is bigger than B, but that's not necessarily the case. We have to see, we have to figure it out, right? So example 11, set A has elements 4, 4, 4, 4, 3, 3, 2, 1, 1, 1, 0, 0, and then that's A. And B has elements 0, 1, 2, 3, and 4. Okay, so you can see that the cardinality of A, I'm going to write it with the N, right? Cardinality of A, how many elements? Well, I only count distinct elements. So 4, I counted once, 3, I counted once, 2, I counted once, 1, I counted once, and 0. How many distinct elements do you see? 1, 2, 3, 4, and 5. So the cardinality of A is 5. You do the same thing with B. Don't do repeats. What is the cardinality of B? Well, 0, that's 1 element. 1 is 2 elements. 2 is 3 elements. 3 is 4, and 5 is 5, and 4 is 5 elements. So B has 5 different elements. B has 5 different elements. So therefore, the cardinality, so they're the same cardinality. That means that they are equivalent sets because they have the same cardinality. Now, if they have exactly the same elements, that makes them equal, because first, for equal sets, they have to have the same cardinality, which they do. Now the next thing to check is, do they have the same elements? And if both conditions are true, if they have the same cardinality and if they have the same elements, if they have the same cardinality and if they have the same elements, the sets are equal. And we see that the sets are indeed equal because they have both the same cardinality and the same elements. All right. So I hope this helped you. This is 2.1. I'm going to end it with this problem because the video did go a little too long, but we needed to get through all of the different types of problems, right? So that you have a model and then you can go and do your homework. All right, so have a blessed rest of your day and many blessings to you. And I will see you in the next video, section 2.2. Okay? You guys take care and God bless. Bye-bye.